Hello guys and welcome back. Today we're going to be looking at how to solve uh, exercises of the following notation. So f of n equals O of gn. Oopsie daisy. We want to prove the following to see if the statement is true. So to do that, we have to first write some definitions. So when it comes to complexity analysis, we use a big O notation to describe the upper bound of an algorithm's growth rate. So describes, as you right here, describes upper bound of an algorithm's growth rate. Given this, we can simply say that for f of n, well, actually, we're just going to take this f of n here that we just rewrote. When it comes to that, it refers to the fact that f of n grows at a rate no faster than g of n as n approaches infinity. So that's important parts. This is important, the definitions. Now we're going to have a mathematical definition, which is going to be given by the following. Let me just copy from here because I don't want to be taking the full thing. So let's copy it. Let's paste it over here. Okay? Let's paste it. And it simply looks like this. The definition for O of n, more than the definition, is mostly like the rule that we have to follow, is that when we want to prove this, we have to check for the following to be true as well. What we check is for f of n be equal to OG of n, we have to do there exists a constant greater than 0, and there exists n0 greater than 0 as well, such that f of n is lower or equal to c times g of n for all n that are greater than n0. Meaning that from n0 towards infinity, we're gonna be, this applies basically. So let's check this out. How do we solve this? Now we're gonna give you an actual exercise of this type of problem. It's really not that difficult once you get to understand it. So yeah, let's go ahead and do that. Let me just open it up real quick. Where is it? There it is. There we go. So let's check this following exercise. Let's say we have, in this case, n cubed equals O of n cubed minus 2n squared. How do we solve this? Well, first of all, we want to see a structure. And we want to focus on two things in our definition. We want to focus on this and on this. These are the two integral parts to solve this type of exercises, right? So let's do it. In this case, we can see that this has the same structure as this, meaning that f of n is going to be equal to n cubed. So I'm going to write f of n is equal to n cubed. And, well, simply g of n is equal to n cubed minus 2n squared. Now, let's do the following. Basically, what you want to do is now check for this guy. We're going to be checking this statement out. So it's right over here. F of n greater or equal to c dot g of n, right? Now we're going to do the replacement of functions. We're going to write in our functions here. C times n cubed minus 2n squared, right? And now we want to clear for c, basically. We want to have c with no n values on the right. So we're going to put all of these guys to the left. So we're going to have n cubed minus 2n squared. Let's see. Now we can actually factor for n cubed. So we're going to do n cubed 1 minus 2, 1 over n, right? C. And then from there, we can cancel out n cubed, which we're going to have at the end, minus 2, 1 over n, C. Now, in this case, what we want to do is we want to write any n, right? So for n0, we're going to have, I don't know, imagine we have 1. So we can write any other number that goes on the top of 1. So let's write 2, for example. And we're going to do 1, 2, 1 over 2 for n. Is going to be lower equal. Let's do, actually, this is not 1, this is 2. And basically what we're going to get is 1 minus 1. Hold on, no. 2 divided by, yeah, it's 1. Right? This is going to be equal to 0 or C, if I'm correct. You divide that. No, actually, this is not going to work. Let's take another number. Sorry for that, guys. We're going to choose any other number that allows us to do this equation. So let's do 4, for example. So we're going to do 1, 1, 2, 1 over 4, C. And then we're going to have 1 minus 1/2, basically. And this is going to be 1 over, basically 1/2, which this turns into 1/2. Basically, is going to have 1. Oopsie daisy. And this is going to be 2. So we're going to have ultimately 2 lower equal to C. So basically, this means that, that C is equal to 2. So now we want to actually try this out and check if this actually works. To do that, we're just going to go with this part of our equation. So let's write it here. And we're going to input n equals to 4 and C equals to 2. So n to the cube is going to be 64. Then C is going to be 2 times 64 minus, this is going to be 4 squared, which is 16. 16 by 2 is going to be 32. So we're going to have 64, 2 times 32, 64, 64, right? And this statement is true, as you can see. Now, in the future, you're going to do another exercise. Right now, we're going to do another exercise in which this doesn't really fulfill. But I explained to you how we can actually prove this. So in this case, our statement is true. We can simply say that n cubed is indeed equal to O n cubed minus 2n squared. Right? Now we're going to do the second one. Let's do the second one real quick. The second one says basically that, yeah, let's just do the second one. Give me a second here. I'm trying to find it here. Let me see which exercise it was. It was actually, it was the third one. Yeah, it was the second one. So let's do it. We're going to write here n 3/2 equals O of n squared. What we're going to do is we're going to take f of n, which is going to be n 3/2. Then g of n is going to be n squared. And now we can do our simple, well, equation. This is going to be n 3 squared, inequality more likely. We're going to do c times n squared. We're going to move the 3 squared to the other side. We're just going to have ultimately like so. And this is basically just 3/2 minus 2, which is going to be 1/2 minus 1/2. So we're going to have 1 over n of 1/2. C. From there, you can simply see the following statement is that, yeah, that this is going to be equal. Why? Because as n grows, you can see here, as n grows, meaning if we start with 1, 2, 3, 4, 5, up until 1 million, for example, 1 over that is going to be smaller and smaller than our constant. So this is actually true. The inequality is fulfilled. Therefore, we can say that n 3/2 is O of n squared. Now, we can simply give you the further calculations like we did before. So when we wanted to take an n, let's say we take 10, right? Let's do something simpler. Let's do 25, for example. 1 over n, 25 to the 1/2. That's basically going to be 1/5. Why? Because 1/2 is basically the square root of something. So we're going to have 1 over 5 lower equal to c, right? And that is actually true. If we take, say, that c is 3 or 4 or 5, this will be fulfilled. Let's take another example. Let's take 3. I'm going to say n cubed is equal to n 10 to the 6th n squared, right? So f of n is n cubed. G of n is going to be 10/6 of n squared. We're going to do the same work here. As easy as that. We're going to input our numbers here. We move n squared to the other side, so we're going to have at the end, we're going to have c times 10 to the 6th. So what does this entail? Well, this means, for example, that if we take n as 1, it'll be obviously smaller than this, right? However, if n, approaches 1 billion, for example, imagine we have 1 billion, or a really big number, I'm not sure if that's 1 billion, right, as our n, and we have, say, 10 as our c, that's a constant, this will overpower this, meaning the inequality is false. It cannot be true. Because at the beginning, it will be fulfilled, but we want to check for all n's that are greater than n0, meaning we're going to be checking as n approaches to infinity, and as n approaches to infinity, this is not fulfilled. So you can simply say, not true. Meaning that this whole thing, this whole chimichanga, is not going to be equal to. So that's pretty much it for today. Another example that I want to give you guys is the following. I'm not sure if I can show you here, but let me just check if I actually can. I really wanted to check this out. Yeah, this is my pictures or whatever. But I want to show you this. Oopsie daisy. Okay. Okay, this is not working. Sorry about that. Basically, let me just import a photo here, or photos. Let's import this here. And we want to see this. Oopsie. So, yeah. Oh, man. Why does it look like that? I ruined the video, guys. I am sorry. Just give me a second. There we go. Or presentation. Display size. Okay. There we go. I'm sorry about that, guys. So, I want to give you this example here. In this case, we have all these tables. And as you can see, we just worked with O of n, right? But we can also work with omega of n, or this delta of n, or little o of n, or omega of n as well. And we just have to follow up the rules here, which are the important parts are basically this, guys. This, 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 and this, right? This is the important sections that we need, so to speak. We also need to just understand the concepts, and once you get them, it's really not that hard. It really isn't. So yeah, thanks for watching, guys. If you have any more questions, let me know. I can maybe upload another video. And yeah, that's it.